Hi guys and welcome. In this video we're going to learn about simpling rational expressions. So remember, the word rational means fraction. Okay, so all these expressions are going to have fractions in them. Okay, now we've been dealing with fractions all year long really, but in this one we're going to focus specifically on how do you handle problems where there's more than just numbers in your fractions. Okay, let's get started. So the first thing we got to do is we got to simplify each. Now when we're simplifying, remember, when we're dealing with fractions, this is basically division. Okay, so 6 over 3 is equal to 2. Okay, I divided 6 by 3. Okay, p squared over p is a p. Okay, because I have 2 p's in the numerator. 1 on the bottom cancels, 1 in the numerator cancels, and I'm only left with the 1. So I'm dividing. I may use these other words like simplify or cancel. But the main thing to remember is that at all times I am dividing. Now the reason why this is important is because in this worksheet and in this whole chapter, what we're looking for is a number over itself. Okay? Because whenever you divide a number by itself, that number will always equal 1. Even when it works with the variables too. If I have x over x, x divided by x is 1. Okay? So throughout this entire worksheet, I want you to remember this fact, that if you divide something by itself, it will equal 1. And no matter what language we use, whether we use cancel, whether we use simplify, we are looking for a number divided by itself. That being said, let's get started. I'll change color so I can leave that up for a little bit longer. Now in this first problem we've seen before. We've got 36p over 12p, so I'm going to divide. I'm going to divide my numbers by 6, and that means this will cancel and become a 6. This will cancel and become 2. So now I have 6 over 2, p over p. Okay? Now as I'm looking at it again, I can see I can go further. 6 divides by 2, and I haven't even touched my p's yet. So this will eventually simplify down. This will turn into a 3. This goes away completely. And then my p's cancel out completely. Or they divide and become 1. P divided by p equals 1. So my answer is just 3. Okay? Let's go down to number 2. Same process. 60 divided by 36. Okay, both of these have a 6 in them, so I'm going to divide both by 6. So this would be a 10, and this would be a 6. Now I'm going to go to my variables. I have an m squared, which means I have 2 m's in the numerator and only 1 m in the denominator. So I'm going to divide. 1 in the numerator goes away, and this one divides away. So in my numerator, I'm left with 10m over 6. Now my numbers can divide further. They can simplify further. I'm going to divide a 2 out of each. So 10 divided by 2 is 5. And then 6 divided by 2 is 3. So 5m over 3. Okay? And that would be your answer. And before we go on, a couple rules I want to talk about that you may have noticed, but I want to definitely say it out loud. Number 1 rule, I'll write this in red. Number 1 rule, you can only divide the same number from the top and the bottom. So you can't divide a 10 from the numerator and then a 3 from the denominator. It doesn't work like that. So you have to find the biggest number that goes into both your top and your bottom. And then, as I did in both problems, sometimes you can pick a smaller number and then divide it again. Okay, but the thing to remember is you're dividing the numerator by the denominator. So you always have to divide the same number from the both of them. Number 2 rule, don't lose your variables. Okay, there will be some times that happen, like in problem number 2, where you get so used to scratching out, okay, this divided, this canceled, that you forget there was an m in the numerator. Okay? Always keep an eye on where your variables are and notice what you have and have not canceled out. Finally, last rule, watch your signs. Okay? Signs are very important as we go through this. In order to divide something, they need to match. Okay? And I'll explain that as we get on to further problems. But watch your signs and make sure you don't lose anything. All right, now the nice thing about both of these first two problems is that it was a monomial over a monomial, okay? One term over one term. As you're looking down, probably, you can see 3 and 4. I'll leave my rules on the screen. You can see 3 and 4 are no longer a monomial over a monomial. We have a binomial over a monomial, and in number 4, we have a binomial over a binomial. All right, so let's work on these. Now, number 1 rule, or I guess at this point we're actually on number 4. You need to remember there is no dividing out of addition and subtraction. You can only divide out of multiplication. So as I'm looking at problem number 3, and I'll do this in blue. As I'm looking at problem number 3, currently everything is wrapped up in addition and subtraction. I can't divide anything just yet. So the first thing I need to do is check for my GCF. Here I'll do tips in blue. Okay, so as I work out this problem, I see in my numerator that I have 21b plus 9. Well, both 21 and 9 have 3 in common, so I'm going to pull 3 out of my numerator. This leaves me with 7b plus 3 divided by 15. See, now I have multiplication in my numerator. I have the GCF times a binomial. And that means I can divide because I am multiplying in my numerator. So I'm going to divide 3 and 15. Both of them have a 3 in them, so I'm going to be left with a 5 in my denominator. My final answer for this is going to be 7b plus 3 over 5. Okay? Now remember, you divided, so the 3 goes away because it's only left with a 1, and we don't need to leave our 1s there. Yeah, this problem shouldn't be a surprise to you. Maybe it's not your favorite problem, but it shouldn't be a surprise. Number 4 is where we start getting into completely new content. Okay, so let's work this one out. First, I'm going to check for my GCFs. I don't see one in the numerator, but I see one in the denominator. So I'm going to rewrite this as p plus 10. Nothing changes in my numerator, but in my denominator I can pull out a 5. And here's what I want you to notice. In my numerator, I have p plus 10. In my denominator, I also have p plus 10. Here is a binomial that matches completely. Signs are the same, numbers are the same, everything is the same. Okay? So by definition, anything divided by itself is equal to 1. Remember, if I have x divided by x, that equals 1. If I have 3 divided by 3, that equals 1. Well, the same thing applies here. P plus 10 divided by p plus 10 equals 1. So I am now left with 1 over 5. Okay? And that is what we're doing for the rest of this chapter. The strategy for this chapter is you have to factor, you have to do the GCF, you have to pull things out until you have a number divided by itself, or an expression divided by itself. Once you get 2 expressions that match exactly, then you can divide them, and whenever anything divides by itself, it equals 1. Okay, so let's keep going. Now, for numbers 5 and 6, as you can see, we have a bit more of a complicated problem. Don't panic, we know how to do this. In my numerator, I have 3 terms, so your first thought should be factoring. I told you it wasn't going to go away. So when I'm factoring, I need 2 numbers that multiply to 50 and add to 15. That's going to be 5 and 10. So I have x plus 5. I'll do 10 first. And then x plus 5. Okay. Now remember, signs matter, okay? Things have to match exactly, so make sure you watch your signs. Now in my denominator, I only have 2 terms, so factoring isn't going to be my first option, but They both have, I have 9x squared plus 45x. They both have a 9 and an x in common. So I'm going to pull out a GCF of 9x to the front, and I'm now left with x plus 5. Okay? Now that I've factored everything out, I'm going to check to see if I have a number divided by itself or anything else that will simplify. Okay? And I do. I have x plus 5 in the numerator and x plus 5 in the denominator, so this will divide and become 1, and I am left with x plus 10 over 9x. Let's go on to number 6. Now in number 6, we have x squared minus 5x minus 50 in the numerator, and 50 plus 5x minus x squared in the denominator. Now immediately I have a small red flag because I see all the same numbers. But my denominator is kind of written backwards. So I'm going to rewrite it so that all the terms match up. Okay? In math, this is a good strategy. You always want your terms to match exactly. Okay? Make sure you carry the signs with you. Those are important. So there's my problem. And I noticed that I was correct in my first warning. We do have the same numbers, but we have opposite signs. Okay? Now, we can only simplify and we can only divide if the expressions match exactly. So, for all those who remember, here's another tip. We learned a few chapters ago that if you want to change your signs, you either multiply by a -1 or you factor a -1 out of your problem. Okay? Now, in the spirit of everything we've done this worksheet so far, I'm going to go with the factoring option. So in order to get my signs to match, I'm going to factor a -1 out of my denominator. So my numerator is going to stay the same. And then I'm going to factor out a -1. And look how that changes my signs perfectly. Okay, and this is why I was saying signs matter. They really do. If they don't match, then you have problems. Okay, so now that my signs match perfectly, I'm going to factor my numerator and my denominator. Two numbers that multiply to -50 and add to a -5 is going to be a -10, +5. So I'm going to do that over here. I have x minus 10, x plus 5 in my numerator, and then I have -1 out front, x minus 10, x plus 5. Both my numerator and my denominator match exactly. So this will divide into a 1. This will divide into a 1. And I'm left with 1 over -1, or just a -1. Kind of cool how that big problem simplifies into a -1. Okay. Now, if you were experienced and you've been doing this before, you actually could have simplified from over here, since this is the first step in which your numerator and your denominator matches exactly. But as some extra factoring practice, go ahead and take it to the third step where you factor both your numerator and your denominator, because not all problems are going to factor nicely in the second step. Okay? Like I said, that's only for if you've been doing these problems for a while. Okay, last two problems. And since I shifted my screen, I rewrote my tips. Number 1 tip is to look for a GCF. Number 2 tip is to factor. And oftentimes you'll have to do both. Okay? I told you those two things weren't going away. Here they come. Alright, so in number 7, I look at this problem. My numerator, it's a trinomial. I don't see any GCFs, so we're probably only going to have to factor that. Okay, now my denominator, I see a trinomial, but there looks to be an extra n. I have n cubed, n squared, and then an n in the back. So I'm going to pull my GCF out first before I factor anything, just to see what I'm looking at. So I'm going to rewrite this as n squared plus n minus 2. And then I'm going to pull out my GCF of n. And now I have n squared minus 5n plus 4. Okay, I can factor my numerator now and my denominator now. So that's what I'm going to do. In my numerator, I need two numbers that multiply to a -2, add to a +1. That's going to be n plus 2, n minus 1. Oops. Should be an n in that first term. Now, in my denominator, I have my GCF, so carry down your GCF, and I'm going to factor the denominator. So I need a number that multiplies to 4 and then adds to a negative 5. Okay, well that's going to be 4 and 1. N minus 4, n minus 1. Again, always pause, check your signs, check your numbers. They have to work, otherwise you're going to run into problems. But as I look at this problem, I see that I have an n minus 1 in my numerator and an n minus 1 in my denominator. So that will divide and become 1. And then nothing else matches. So now I have n plus 2 in my numerator and n minus 4 in my denominator. I'm going to check one more time to see if anything will simplify, because sometimes it is helpful to do one step at a time. That way you don't get things lost. Since nothing else simplifies, I'm going to redistribute my GCF back in. Okay, and the reason why we do that is because you always want the simplest factors and complete things in your fraction. So it's the exact same logic as if we have a 3 and then a 4 times 2. Okay, you wouldn't leave it as 4 times 2 in the denominator. You would go ahead and combine those and get 3 over 8. Okay. Last but not least, our final problem. It looks scary, but we can handle it because we're going to look for a GCF and then we're going to factor. In my numerator, oh that's nice, in my numerator it's 56x cubed and 56x. I can pull out a 56x out of my numerator. I'm only left with x squared minus 1. Ta-da! Remember, if you end up pulling an entire term out, like 56x, you still need that spot, so you leave a 1 as a placeholder. In my denominator, I see a lot of big numbers, but I see that my GCF is going to be 40, because 40 goes into all of these terms, and x, because I have an extra x. So 40 is going to come out, and an x, and that's going to leave me with x squared minus 3x plus 2 in my denominator. Now, not always, but typically speaking, whenever you have a trinomial, there's a good chance it'll factor out, okay? Which means you can factor it and divide something from the numerator and the denominator. So since I see a factorable expression in my denominator, I'm going to look at my numerator again. X squared minus 1. If you remember, excellent. If you don't, the third tip is difference of two squares. Okay, this was back in chapter 8. We learned that if you have, say, x squared minus 4, a square minus a square, this will be equal to x plus 2, x minus 2. Okay, this is called a difference of two squares. As I look in my numerator, I see x squared minus 1. That is a difference of two squares. I can simplify this further. And that's going to be a trick problems will do to trick you up, because you may have forgotten this one. But if you remember this one, you can expand it a bit more. I'm going to factor my denominator. Two numbers that multiply 2, add a negative 3. That's going to be a negative 2 and a negative 1. And now I have a hidden factor that is now revealed. So x minus 1 will divide and become a 1. Over here, my numbers will divide. I can get an 8 out of my numerator and my denominator. So this is going to divide and become 7. This will divide and become 5. And my x's will also divide and become 1. So I got a lot of things going on over there. I'm going to rewrite this. In my numerator, I have 7. I don't need to write a 1. X plus 1. and then I don't need to write my other 1, divided by, I have 5 in my denominator, and then x minus 2. Since nothing else will factor, I'm going to go ahead and distribute again, combine like terms as it were, and my answer is going to be 7x plus 7 over 5x minus 10. Okay. As you can see, this section uses a lot of old knowledge. Okay, factoring comes back, dividing comes back, a lot of chapter 8 stuff comes back. But if you can remember those things and remember your tips, GCF, factoring, and difference of two squares, you can handle these problems quite well. Now, the last thing I want to talk about is actually at the top of the worksheet. Now, when we were going over this, I focused first on just simplifying everything, because that's the first skill you need to know how to do, simplify stuff. However, I did not talk about this vocab word of excluded values. Okay? Excluded values is a vocab word that means solutions that don't work. Okay? It's very similar to extraneous solutions. Remember, when we're doing this, all of our answers need to be able to match up with the real world, with life. Okay? All the rules combine in math. One just doesn't go away. Okay? And since we're dealing with fractions, one of the biggest don't do's is you cannot have a 0 in your denominator. If ever you have a 0 in your denominator, it won't work. Okay? The math world blows up and everyone dies. So excluded values is when you look at the problem and say, what cannot happen in the denominator? So my first problem, I'm going to look at my denominator. Now it's the denominator of the original problem, not the one you solved for. And I see that I have a variable in the denominator. Whenever you have a variable in the denominator, you're going to have an excluded value. In this case, it's whatever number makes the denominator 0. In this case, my excluded value is going to be 0. So I'll do EV, excluded value is 0. If P ends up being 0, the math universe explodes because my denominator will be 0. Now, it won't always be 0, and you won't always have an excluded value. Take number 3, for example. I don't have a variable in my denominator, which means I don't have any excluded values. There's no way for this to be 0. Now, take number 4, for example. This is an example of how P won't always be 0. Okay? Because if P was 0, then we would still have positive 50 in our denominator. And that means the denominator wouldn't be 0. The way you find this excluded value is to look at the factored form of the denominator. You're going to look at the factored form of the denominator and you're going to solve for P. So I'm going to take my piece of the variable. I'm going to go P plus 10 is equal to 0, and P is equal to a negative 10. Negative 10 is my excluded value. Okay? P cannot be a negative 10, otherwise the denominator becomes 0 and the math world explodes. Okay? So that's what you're going to do with these problems. Whenever you're looking for the excluded values, you're either going to look at the original problem and ask yourself, what number makes my variable 0? Or if you have a binomial or a trinomial, you're going to factor and then solve for your variable. Okay, so in number 5, I have 2 variables, which means I can factor. So I would look at my factored form in this problem. Okay, and then x would equal 0 and x would equal a negative 5. Which means my excluded values are going to be 0 and negative 5. The last problem we're going to look at is down here at number 7. So I'm going to find my excluded values from number 7. Now what's interesting about number 7 is I pulled out a GCF first. So in my denominator, I have 3 terms with n in it. I have this one, and this one. I need to set all three pieces equal to 0. So my answers are going to be n is equal to 0, 4, and 1. So my excluded values at the end of the problem are going to be 0, 4, and 1. All right, that's it. I'll see you next time.